right here, we are recording, by the way. Number 1 says write a verbal expression for 3x to the 7th divided by 5. So what we want to start out with is the word quotient. Okay, so we're going to say the quotient of. So we're going to start out with quotient because this division bar, the fraction's quotient. So we're going to say the quotient of something and something, right? The quotient of this and 5. So the quotient of blank times blank. So what would that be? 3 times a number x to the 7th power and 5. Easy peasy, lemon squeezy. Moving on, number 2. And please feel free to pause, copy this down, and try to do it, and then we're going to go over the explanation. Feel free to raise your hand and stop me if you have any questions here. We're going to begin, and since it's a fraction, let's simplify the top and then simplify the bottom, and at the very end worry about dividing. So up on top, we have exponents. We have multiplication, subtraction, multiplication, and exponents. So obviously we're going to start with the exponents. So we're going to do 6 squared, that's 36. We're going to have a times 4, a minus sign, a 6, a times 16, because 4 squared is 16. And it's still over 6 times 4. I'm just going to rewrite it as 24. Now up on top, we still have multiplication here and here. So 36 times 4 is 144. And we still have the minus sign here. And how about the 6 times 16? It's 96. And we still have the division bar. We still have the 24. I hope we all see how this is just being rewritten right below. So 144 take away 96 happens to be 48. So when I do the top, I'll get 48. And on the bottom, I have 24. All you got to do is divide 48 by 24 at the very end, and you will get your answer, which is 2. So the answer is 2. Ta-da! Piece of cake. Moving on. Let's not waste any time. Get as many questions in on this video. Number 3, how many outfits are possible for Jake if he has to choose from one of each? This is the counting principle. All you got to do is take the 4, take the 10, take the 6 and the 2 and multiply them all together. 4 times 10 is 40, times 6 is 240, times 2 is 480. Isn't that right? So the final answer is 480 outfits. Any questions on that? It's just the counting principle. It will be that easy on tomorrow's midterm. Number 4, write the equation of the following sentence, then solve the equation. Okay, less than. What does less than mean? Less than means subtract. So it does imply a switch. So if I say 1 less than your age, 1 less than your age, you're not going to leave it 1 minus your age. You're going to flip it and say your age minus 1. So less than, it means subtract, but it implies a switch. So let's put the minus sign that's representing less than right there. And the 7 that's in the front, let's actually, this 7 right here, let's actually put it back here. Okay? And what's in front? 1/4 of a number. So let's put the 1/4 of a number right in front. 1/4 of x, or 1/4 of n, or whatever you want to call it. Now it does say is means equals, and 3. So we're just going to put the 3 over here on this side. So ladies and gentlemen, we have an equation with the fraction. And we could solve this now. We could simply solve it by adding 7 to both sides. Plus 7, that'll cancel it out. Plus 7, you're going to get 10. So let me rewrite this thing over here on the side. We're going to have 1/4 x equals 10. And for our final step, to get rid of the 1/4, what do? Times 4, that's right. And times 4 cancels out. X equals 40. That's how old I am. That's right, I'm getting old. 40. Moving on to number 6. Simplify. That's just saying distributive property and combining like terms. And exactly in that order. You want to distribute always first. This positive 5 times a negative 7 is a negative 35. The positive 5 times a negative 7x is a negative 35x. Out here in the front, the 7x is just going to come down. Let me just rewrite it down here. 7x in front of the minus 35 and the minus 35x. Now, out of those three terms, I could combine the x's with the x's. So 7x take away 35x is negative 28 with an x, and bring down the minus 35, and we are done. Negative 28x minus 35. On tomorrow's midterm, you will be able to use calculators, guys, so don't be scared with the multiplication. Check out number 7, ladies and gentlemen. Is the following relation shown on the graph a function? Don't get confused with that. Okay, why not? It doesn't pass the vertical line test. So if I were to draw a quick vertical line, and if I were to take that vertical line and move it left to right, right here, bam, it has a bunch of points in common. All these points are in common, so that fails, that makes it fail the vertical line test. Right here it's cool, right here it's cool, but once it gets to this one, it also fails the vertical line test. So is this a function? You're going to say no, not a function. Okay, it is not a function. You guys get it? Yes. Okay, let's move on to number 8. Solve. That's a simple equation. You're going to have something almost exactly like it on tomorrow's test. How do you get rid of the fraction? Times 7 cancels out. What you do to one side, you do to the other side. You will have 5k left over equals 70 plus 35 is 105. Yay? Or nay? 105. And now let's get rid of the 5 by dividing by 5 and dividing by 5. Final answer will be 21. K equals 21. Okay. And now let's move on to the next one. On the following section, please state the properties illustrated. You want to choose from associative property, commutative property, identity, inverse, and distributive. And there's only 2 examples here. What example is number 9? Associative, are you sure? Yes. The parentheses are around the 3 and the 4, and then over here they're around the 2 and the 3. 2, 3, 4, 2, 3, 4. Order does not switch. So this is definitely associative of addition. Associative property of addition. Okay. Now the bottom one, number 10, what's that one? That's commutative. Now some of us are thinking, wait a minute, that also has parentheses. But the truth is, nothing. The parentheses don't move around. It's just the order of the 4 and the 3 that gets switched right here. It becomes 3 and 4. So the 4 and 3 become 3 and 4. It's an order switch, and whenever it's an order switch, it's commutative property that we see up here, and it is commutative property of addition. Moving on. 11. Baseball. The table shows the number of hits Marcus made for his team. Find the mean, median, and mode, and range. Okay, so in case you forgot, to find the mean, you're going to add up all the numbers. Again, we're talking about mean here. To find the mean, you're going to add up all the numbers and divide by the number of numbers. So we have 3 plus 8 plus 5 plus 2 plus 3 plus 9. And then we're going to divide it all, once we get an answer to that, by 1, 2, 3, 4, 5, 6. And that'll give us the mean. Okay? So let's actually do this. What is 3 plus 8? That's 12 plus 5, 15.
30. 11. 30.
Yeah. 30. Okay? 30. And 30 divided by 6? 5. Sorry. Trying to rush through this. I'm messing up. So the mean is 5. That's the mean. The mean. Okay, not funny. Anyways, the mean is 5. Let's go to median. The only way to find the median is to put them in order from smallest to greatest and then find the middle number. So the smallest number is 2, and then we have 3, and then another 3, and then we have, what else? 5, 8, and 9. Okay, so the median, you could just do it visually. Here's 2 and here's 9. Move it in 1, move it in 1. Move it in 1, move it in 1. And now we don't have a middle number. So you add them and divide by 2. So you're going to take 3 plus 5 divided by 2. That's going to be 8 divided by 2. So your median is 4. The mode is the one that occurs the most. So that would be the 3 because there's a 3 there and a 3 there. So the mode is 3. And last but not least, the range, it's the biggest number minus the smallest number. So for the range, let me zoom out a little here. It's going to be the biggest number, which is 9, minus the smallest number, which is 2. So the range is 7. The range is 7. There will be a question like that on tomorrow's test. I hope we understand that. Name the sets of numbers with the following... No, wait. Name the sets of numbers with the following... No, what? Okay, I misspelled that. I apologize. What I'm trying to say is, name all the groups that this number belongs to. Is it just a whole number? Is it just an integer? Is it just a rational or irrational? Or is it all of them? Who knows? So in order to determine the classification of this, you need to know what the answer is. What's the answer to the square root of 25? 5. So you're really classifying the number 5. So is 5 a whole number? Yes, so it's whole. Okay, let's write that down. What else is 5? Is it an integer? Yes, integer. What else is 5? Is it rational? Yes, it's rational. It's definitely not irrational. And that's it. Those are all the groups that 5 belongs to. Number 13, the square root of 22. First of all, could you find a nice answer to that? No. If you did it on a calculator, it would be a crazy, crazy decimal. That tells you already that it's what? Irrational. That's right, irrational. Irrational is the answer to number 13. Number 14, what is the square root of 4? The square root of 4 is 2. Now, let's not forget about the minus sign that's in the front. So if I do the square root of 4, I get 2, but then I bring down that minus sign, and my answer is actually negative 2. So I need to think about classifying negative 2. Is negative 2 a whole number? No, it's not a whole number. Is it an integer? Yes, so you would classify it an integer. What else? Is it rational? Yes, it's rational. What do I mean by that? Could you write negative 2 as a fraction? Yes, you could put it negative 2 over 1. Could you write it as a decimal? Yeah, you could put it as negative 2.0. And that's it. It's not irrational, so it's just those two groups that it belongs to. Now, number 15, is number 15 the fraction 3/5? Is it a whole number? No. Is it an integer? No, it's not an integer. Integers are nice negative numbers, right? Like negative 3, negative 5. This is a fraction, and a fraction is really a ratio, and the word ratio is inside rational, so the only thing it is rational. It does make sense, though. It's not irrational. It makes sense. It's rational. So I hope that clears that up for you. That is on tomorrow's test as well. Let's move on to the next side of this presentation.